This is Friday's lesson. This is Friday's lesson in case you missed class. And I have to do this anyway, so I might as well talk through it. So we're starting class with just a question. What is the cube root of -8? And you have done this, in fact, in Algebra 1. Had you been in Algebra 1, you would have said, okay, x cubed is -8. You would have taken the cube root of both sides, and you, in dealing with only real numbers, would have said, well, it's -2, because -2 cubed is -8, and that was our understanding of cube roots. That number, which when cubed, gave you a -8. When you were in Algebra 2, it got a little more difficult. Again, we're still looking for the cube root of -8, but you might write this as x cubed plus 8 is equal to 0. And in fact, we're looking for all solutions to this. And you might remember from Algebra 2 that if you have something to the nth power, then we're going to have n roots. So I know we're going to have 3 roots. And you might factor this. You know that this is the sum of 2 cubes. So you might factor this as x plus 2. And then you have x squared minus 2x plus 4 is equal to 0. The first part, we really have to use the zero product property. So we have x plus 2 is equal to 0, or x squared minus 2x plus 4 is equal to 0. The binomial part, we know just, we can solve easily. X is just -2, which in fact agrees with what we had earlier. But for the second factor, we have to use the quadratic formula. So that gives us x is 2 plus or minus the square root of 4 minus 4 times 4 is 16 all over 2, which gives us 2 plus or minus the square root of -12. I'm going to write that as I root 12 over 2, which gives us 2 plus or minus 2I root 3, simplifying, all over 2. So we end up with 1 plus or minus I root 3. So we have 3 solutions. We have -2, we have 1 plus I root 3, and we have 1 minus I root 3. Okay, now, however, we are in Math Analysis and Trig Honors, so let's just do this a little bit differently. We're looking for some number which, when cubed, is going to give us a -8. So in other words, we're going to have some number which, when cubed, so we have r cubed, and we're going to have cosine 3 theta plus I times the sine of 3 theta is going to give us a -8. And what we could do is we could write that -8 as -8 plus 0I, and in fact, this we can put in polar form. This really is going to be 2 times cis. I'm just going to write that out because I'm running out of room here. Well, I'm thinking of this. Here our angle is 180 degrees. So cis 180 degrees. Well, if we just look at what we have here, well, this tells us r cubed is 2. So r must be the cube root of 2. And we know that 3 theta must be 180 degrees. So theta must be 60 degrees. Well, that only gives us 1 root, right? So that gives us cube root of, I'm sorry, this is cube root of, this is 8. Cis 180. So r cubed is 8. So that gives us r2. But this only gives us 1 root here. So this gives us 2, and cis 60 degrees we know is going to be 1/2 plus I root 3 over 2. So that gives us 1 plus I root 3, which does agree with something with which we had gotten earlier, but not the other two. And here's our problem. When we said this is 8 cis 180, 180 is not the only thing we could have done. The other thing I know is that this would have worked had I added another 360 to this. So another option is that we could have had 8 cis, well, 180 plus 360 would have been 540. Or we could have had 8 cis 900. Or we could have had 8 cis 1260. In which case, if this is r cubed cis 3 theta, then r is still going to be 2, but in this case, theta is going to be 540 divided by 3 is going to be 180. So that would give us, come over here, 2 cis 180, which becomes 2 times -1 plus 0i, which in fact is the -2. This gives us 8 cis 300, which I know is in the fourth quadrant, so this becomes 8 times 1/2 minus root 3 over 2i, which is, 2. That's 2, which gives us 1 minus root 3i, which is what we had. And this is going to give us 2 cis, 1260 divided by 3 would give us 420. But in fact, 420, if I subtract out the 360, is really, this is the same as 60 degrees. So we already had mentioned this. So what we end up with are 3 roots. And now I'm going to go through this in kind of a more orderly fashion. So here's what we have. We're looking for all the roots of -8. So what we have is r cubed cis 3 theta is going to be 8 cis 180 degrees. So we can match up our pieces. So r cubed is going to be 8. So r, no matter what we do, is going to be 2. 3 theta is going to be 180 degrees. So theta is going to be 60 degrees. So one solution is 2 cis 60 degrees, which becomes 2 times 1/2 plus root 3 over 2i, which becomes 1 plus root 3i. Another possibility is that instead of 180 degrees, we have another 180 plus 360, so that 3 theta, so our other option is 3 theta is 180 plus 360, 540, which means that theta is going to be 180. So our solution there is 2 cis 180, which becomes 2 times -1 plus 0i, which becomes -2. Another solution is -2. A third possibility is that 3 theta is, well, let's take our 540 and add another group of 360, 900, which means that theta is 300 degrees, which means we have 2 cis 300, and 300 is in the fourth quadrant, and I happen to know that the reference angle is still 60 degrees, so that's going to be 1/2 minus I root 3 over 2. So yet another root is 1 minus I root 3. And again, since we know we're looking for a cube root, in other words, x to the third is equal to -8, we know we're going to have 3 solutions. And here they are. And the other thing that's interesting is if we plot these, let's say we have 1 plus root 3i. So this is 2 cis 60. It's easier to plot that. Our r value is 2. Our angle is 60 degrees. The other is -2 plus 0i. So our radius is again 2. And the third one is going to be in that fourth quadrant. And this is 60 degrees. So what I notice is for each of these, the radius is 2, and they are spaced 120 degrees apart, which makes a lot of sense.